Video to video involves using certain elements from a reference video, combined with prompts and new instructions to generate a new video. The most common use case is referencing the movements of a character in a video to generate a new video where a different character performs the same actions. This is called motion transfer. It can also be used to transfer the style of the video frames, for example, changing them from realistic to anime or from urban to cyberpunk, thus achieving style transfer. Additionally, you can keep most of the original video's content unchanged and only replace a specific region or character, enabling video editing or character replacement. In the early stages of AIGC, we primarily relied on ControlNet to process the reference video frame by frame, generating corresponding pose, motion, and depth maps. Then, AnimateDiff was used to generate new video frames, while style reference depended on IP adapted. However, things have become much more convenient now. Many models now support directly using a reference image along with a control video to generate new content, including models like WAN 2.1 VACE, WAN Fun, and LTXV. Among these, the most versatile solution is WAN 2.1 VACE. The 4 letters in its name stand for Video All-in-One Creation and Editing. It supports using control videos to drive generation and also allows various types of video editing. There are also more specialized solutions tailored for specific needs, which can deliver better results in fixed scenarios. For example, WAN Animate for motion transfer and character replacement, and Live Portrait for expression cloning. In the following demonstration, I will first use WAN 2.1 VACE for style transfer, converting a realistic character video into an anime-style video. Then I'll show how to use WAN Animate for motion transfer, making a new character dance in sync with the reference video. Let's load the VACE workflow for video reference. I want to convert this realistic video of a person dancing in a field of flowers into an anime style. The officially released VACE is currently only available in the WAN 2.1 based version. However, I am not using the original model here. Instead, I use a new model generated by QuantStack, which merges the WAN 2.1 VACE 14b model with WAN 2.1's fine-tuned model, FusionX 14b, for text-to-video generation. This fused model not only supports all VACE functionalities, but also offers excellent motion smoothness, scene consistency, visual details, and acceleration. It also comes in the GGUF format. I find Q6K to offer a great balance between quality and performance. Although video to animation may sound similar to image to video, in practice it is closer to text to video generation. Besides the main model, you only need to load the text encoder and VAE, which are the same as those used with WAN 2.2 and WAN 2.1. The SLIP visual model is not needed. For inference acceleration and enhancement, since FusionX comes with built-in acceleration, I only enabled Torch's FP16 accumulation option. Depending on region-specific requirements, you can also optionally stack modules like Sage Attention, Tcache, or Enhance a Video. There are 2 main types of input sources. First is control video. Note that the reference video input accepted by VACE is essentially a conditional video, typically depth or pose information. In the workflow, we use a ControlNet preprocessor to extract the character poses from the original video, providing these as control signals. The last input is a reference image. For more effective style transfer, I use the image editing capability of Kontext to convert the first frame of the input video into an anime style, adjusted the dimensions accordingly, and fed it into the sampling stage as the reference image. In video to video, since the control video and reference image provide strong constraints, the text prompts can be relatively simple. Here, I simply describe the subject and the action, a 3D anime-style girl gracefully dancing in a field of flowers. Negative prompts can be ignored, left as default, or set to empty. There are 4 nodes in the sampling stage. The key node for preparing materials is WAN VACE to video, which can simultaneously accept 3 types of signals: control video, control mask, and reference image. Different combinations of these signals enable different functionalities. Since we don't need to mask anything, the control mask is not used here, and the dimensions are kept consistent with the reference image. The frame count is set to 81, which means 5 seconds. I won't go into detail on the sampling node, as all settings are standard options. The main thing to note is that the FusionX version of the model generally only requires 8 steps, significantly saving time. The shift parameter in the upper left has little impact on the result, so I usually leave it at the default value. Trim Video Latent is used to remove excess frames generated during VACE sampling, making it a crucial part of this workflow. The final nodes handle decoding and saving the result as a video, just like in text-to-video or image-to-video generation. If you encounter OOM errors, switch to VAE Decode Tiled. Set the FPS to 16 to match the WAN series models. Click Run, and after a few minutes you will get the result. A cute anime character dancing in a field of flowers. Comparing it to the control video, you can see that the character's movements are perfectly matched in both videos.